Let us now go to the second question in the series. The question says, a compound which gives a most stable carbocation on dehydration. Just to recollect, dehydration is a process which proceeds through a carbocation intermediate. Alcohols undergo the dehydration. You will find all the 4 compounds listed here are alcohols. So alcohols undergo the dehydration reaction, and when they undergo the dehydration reaction, the OH is lost in the form of H2O and leads to the formation of a carbocation intermediate. Then of course the carbocation loses a proton on the adjacent carbon atom to give rise to the olefin. That is the mechanism of this reaction of dehydration. So the question is, therefore the formation of carbocation is a constant factor in all the 4 cases A to D, but which is the most stable carbocation is a question. Now when you look at this various, we will take up one after the other. We will take up first A, B, C and D. In the case of A, what is the carbocation that is going to be produced? The carbocation that is going to be produced is CH3 twice, CH, CH2, this OH goes off, therefore a carbocation, a positive carbocation will produce, or I will write it separately. This will be the carbocation that is going to be produced after the loss of OH. This is a primary carbocation. What is meant by primary carbocation? A carbocation is one which is connected to one other carbon atom is said to be a primary carbocation. Therefore, this is a primary carbocation. This primary carbocation among the carbocations is less stable or least stable. Therefore, it rearranges to a more stable carbocation by a 1 true shift of a hydride. From one position, it moves over to the next position, and therefore this H, that is a hydride shift. Hydrogen is going as a hydride because it has to neutralize the positive charge. So something has to go with the pair of electrons. So this hydrogen goes with the pair of electrons to neutralize the CH2. So as a result, we have CH3 twice, C plus, this positive charge has moved over to this, and this has gone over to the other. The CH2 has become a CH3. This carbocation is produced. So this is the carbocation that is produced in A. Now let us look at the other species, the remaining 3 compounds. Now here a carbocation just similar to this, a carbocation is formed, but it cannot rearrange to a more stable carbocation because it has to come from one of these positions. It is not going to make anything big or anything different. Therefore, this is not a most stable carbocation. What is given is the most stable carbocation. This will after all will give only a secondary carbocation. This will not give tertiary or most stable. Similarly, we have, look at third one, this is only N-propyl alcohol, there is no possibility of any rearrangement. Therefore, this is also ruled out. So this is ruled out, this is also ruled out, and looking at D, this is a secondary alcohol. This is a primary alcohol, the same C4H9, these 2 are isomers. Only thing is position isomers. One is a primary alcohol, the other is a secondary alcohol. That is all the difference. Therefore, this also doesn't give. Therefore, the best answer for this question is A. The one which gives the most stable carbocation is this, which is CH3 twice C plus CH3, or in other words, it is a tertiary butyl carbocation is formed. That is formed by a shift of a hydride from this position to the other position. That is being indicated by means of a 1,2 hydride shift.